All right, let's do just a couple examples. I've got, well, six. I got 6 examples for rational exponents that will just kind of just push this a little bit more forward, so that we can kind of, go through the material a little bit. And it's not me that is sick; it's Lucas. He had 101 fever at school yesterday, so he can't. Even if he felt better today, he actually can't come back to school. So we're gonna keep him home. Let's see, we got a few examples here that I want to kind of show you the kind of operations that make rational exponents so useful. Okay, so imagine then that we wanted to multiply these two guys. They have the same base, right, k, but these would imagine taking the third root and then squaring the k. You can't reduce it anyway. This guy would be multiplying to k, taking the 6th root, but raising it to the 5th power. If you were to see those in radical form, it would feel impossible to multiply. In fact, it really is. You have to basically go to the exponent rules and just treat them like normal numbers. So if we treat them like rational numbers, which they are, okay, we can literally, if this was just a 5 and a 2, we would just add those together. So just because you're taking the roots, 3rd root here, 6th root here, it doesn't mean that you couldn't actually add those together. It's the same rule. It doesn't matter that they're actually rational exponents. So all we got to do is just add these two, okay? And if you remember adding fractions, you need a common denominator. So we're going to multiply this guy by 2. We'll leave this guy the same so that they have a common denominator. And then you'll see that it's 9 over 6, which is can be reduced to, let's see, 3 and 2. So it would be 3 over 2. Okay? So this means that k, these two multiplied together would just be 3 over 2. Now, if we can simplify this a little bit, we can go back to the radical if needed, okay? And I want you to get comfortable going back and forth between radical form, rational exponent form, because they both have their advantages. But if you need to do operations, it's better to just have it as a fraction, okay? So this guy is the square root, but we're raising k to the 3rd, okay? So this and this are equivalents, what we did yesterday. So now what we got to do is we're just going to take out a pair of k's, and we'll have one left over. So this guy and that guy are the same thing. Okay, so that's one example. I'm going to try to make the video a little quicker. You guys can rewind it if I'm going too fast. But what if you got this kind of operation when you've got p to the 2nd and then you've got p to the 1/4 underneath, okay? And that would be the same as this. Now, I'm not going to do anything with this. I just want to show you how weird it would look. Like, imagine, oh man, what is that? Bad cable or something. Yeah, I don't know if you guys can see this in the video, but like my screen is like going a little AWire. But yeah, this would look really strange, okay? So I'm going to finish this problem and then see if I can't fix this. This would be like, how do you do that? But if it's in rational exponent form, we can, because it would be like 2 minus 1/4. And so if we just write this as a fraction of like 2 over 1 minus 1/4, let's give this guy a 4 so that he's 8 over 4. Okay, and just keep going. We could just write it over here. I'm keeping it as an exponent to be, I don't know, cool about it. Now we've got p to the 7th over, oh, it went away. Okay, good. So now we're taking the 4th root, but we're raising p to the 7th power. So whenever you have something where you're taking a root that is smaller than the power, you're going to be able to take stuff out, okay? But you can only take one of those guys out, and you would have 3 left over, because 4 of those, a quadruple would come out, and then you'd have 3 left over on the 4th root. So either one of these are acceptable, but in your work that you do today, it might you might have to choose between one of those two. Okay. All right. So moving forward. So you notice it's really just adding, subtracting fractions, but you're just kind of like, you're kind of doing a powerful thing here, because there's a lot of stuff in science that require like formulas that have like rational like roots and cube roots and quarter roots, and when you have to when you have these kind of skills, it's just easier to manipulate the equations. All right, now this is really no different. We are taking the fourth root but raising it to the third power, but we're like raising it to the 20th and then taking the ninth root. That's really strange, but just follow the rules. Okay, follow the rules. We got m to the 3 times 20 over 4 times 9. So that gives us m to the 60 divided by 36. Okay, you're taking the 36th root, but you're raising it to the 60th power. It might happen sometimes. But we're going to reduce this so that 6 will go into both. In fact, 12 goes into both 5 times and 3 times in the denominator. So this mess right here, if we were to take all the roots and raise all the powers, you end up with just taking the cube root of m to the 5th power. Okay, so that's what this guy would look like. And what would happen is we would take the third root, and we would take out a triple of m's, but we would have 2 left over. Okay, so this one or this one is acceptable, just depending on the context. Okay. All right. Let's see here. This one's a good one. All right, where are we at? We're at 6-minute mark. Good. I want to try to keep this under 10 minutes. 6. I can hear my kids ready to go to bed here in a second. So let me... Now, I know you guys are probably going to need some practice getting comfortable with it, so I don't mean to go too fast, but it's good when you kind of know the whole road, and then you can kind of like do all kinds of things when you know all of the rules. Okay, once you know all the rules, we'll take an hour to kind of like put them all together. Okay. All right, so it looks like these are being raised. Both of them are being raised to the 4th power. Okay, so this is kind of interesting. This you can pull this trick here. You can actually do. Okay, I did copy it down right. Making sure that. What you can do is, since they're both to the quarter power, okay, you've really got this. Okay, because they are both to the same power, we can do this. All right, that is perfectly a legal move here. And so what we're going to do then is we're going to then, and I know it seems weird, but we're going to actually go ahead and take the 4th root, and then we're going to figure out what 27 times 6 is. Okay, that's 12. I hope I don't mess up here. Oh, shoot. 4, 12, 162, and then 162, and then a to the 2nd. Okay, so then we'll go ahead and break this guy up and look for groups of 4 quadruples. We already know that it's 27 times 6, so I know that it's 3 times 3 times 3. That's 27, and then 6 would be those guys. So here's the 9, and then, I'm sorry, here's the 27 times 6. So you can see there's a quadruple of 3's there. So we'll take the 3 out, and we got a 2 left over. And we're definitely not going to take any of those a's out because there's only 2 of them, and you need a quadruple in order to take them out of the radical. Okay? All right. Next one. Okay, this is a good one because we're going to be raising this guy to a power. And then I think this will be it. Okay, we got this guy, and we're raising it to the 3 over 2. All right, now there's a couple, I think the best way, I mean, you could distribute the 3 over 2 to all of them, but there's kind of an easier way because this 2 here means that we are taking the square root, but we're raising everything else to the 3rd power, like we're powering it by 3. So an option here is to look at this like a square root, okay? And we're going to raise all of these to the 3rd power. So 4 to the 3rd power. Now we can do this because 4 is in the parentheses. He's partaking in this. Sometimes they're outside of the power. Like I think there was a problem like this. Okay, like this, the 1/4 is like only on the x, and so this is actually what you have. Okay, the 5 is not included in the power because he's not in parentheses. But if I would have went like this, then the 5 is definitely inside the radicand here. He is part of it. But if the parentheses are not there, this is actually what you have. Okay, so watch out for that. That's a common mistake. So anyways, 4 is in the parentheses, so he's going to get that third power. C will go up to 15, and then D will go up to 6, because remember, we multiply by 3. Okay, so with square roots means that we can take out pairs, okay? And so we'll just take out pairs. We got a pair of 4s coming out, because there'll be one left over. Oh, wait a minute. Yeah, I mean, oh, here, just do this. This is kind of strange, because 4 to the third power is actually 64. Okay, I'm going to do this. 4 to the third power is 64. It's better if we actually figure that out, okay? Because the square root is 64. There's a pair of 8s, okay? All right, now, what would have happened is if we would have taken the 4 out, we would have had a 4 left in there. Then we'd have to take out a pair of 2s. Then the 4 already sitting there would have been multiplied. So we would have got 8 either way. We can take out 7 pairs, and then we're going to take out all 3 pairs right there. The only thing that's left over, it looks like, is just 1C. Okay? 1C is all that's left over. Everything is out, and that's it. That's all I wanted to show you today. Just 5 examples on where this stuff goes. You know, you might have been able to figure it out on your own, but I just figured it's probably better if I explain it just a little bit more before I turn you guys loose on these mazes today. All right, and I will see you tomorrow. Have a good one.